Hey, Poon.
Hello, James.
How are you doing?
Hi, how are you, James?
Hey,
Hello,
David.
David.
Hey, John.
Hey,
Happy
morning, guys. Happy New Year.
Yeah, Happy New Year, everyone.
Happy New Year.
Boon, quick question for you. What time zone are you in?
Malaysia.
Malaysia. Okay. Here's Tony.
Hey, Tony.
Hey guys, Happy New Year.
Happy New Year, Tony.
Yeah.
Happy New Year.
Okay. You know what? I'm gonna add a line like this. No, okay. And start a new page. Why don't I do like this? Okay. Wow. 2024. Boy, this is gonna take some getting used to.
Right.
Hi, Mark. Okay. Why don't we, what time is it? Yeah, let's get started. So, a couple of updates before we get started. White paper, I need to follow up with Bapi, where we are. To follow up with Bapi about publishing and all that stuff. I did share the white paper. A couple of people were interested in reviewing it. Wanted to see, I haven't heard any feedback yet. So wanted to see if there's any feedback and see what the next steps are. Worst case, the white paper needs to be reviewed by the server team on the 24th. I'm hoping that they'll be able to review it before that and basically get it published. But the idea is to have everything published end of January so that for the Chiplet Summit we're ready to go. That's my quick update on the white paper. On the agenda today, we have James is going to talk about MDK, give us a quick update. And let me copy this. So James is going to talk about that. Kevin seems he's ready to present next week on federated simulation for triplets. And I thought I'll do a quick update, quick proposal for CDXML 2.0. on January 18th, 2024. I'm going to share some thoughts about some proposals how to enhance it and make it more flexible, more interesting. I was thinking, and I wanted to get your thoughts on this. We usually run the meeting for 1 hour. I was thinking in 2024, I'm going to make all my meetings to be actually 5 minutes shorter, to be 55 minutes, to give us a little bit of time in case we go over, or a little bit of time between meetings. What do you guys think about that?
Yeah, that's a good idea.
Yeah, that's good, David.
Yeah. I think I'm gonna make all my meetings 50. Yeah, okay. I will update the invite then for 55 minutes. So that we have a little bit of 5 minutes to shuffle between meetings, right? Get some coffee. Okay, I'll do that. 55 minutes. Okay. Before I hand it off to James, and anybody, any urgent issues that would like to discuss? I think we're going to have some time after James is done with his presentation as well. So unless it's super urgent that needs immediate attention, we can talk about it after James is done with his presentation. Okay. All right. James, are you ready?
Sure. Let me
Go ahead and share.
sharing. Can you stop sharing so I can? Yeah.
Oh, okay.
All right. Thanks. All right. Can you see my screen?
It's still coming up.
Can you see my screen?
Not yet.
No.
It says James has started screen sharing, but that's about it.
Oh, hold on. Let me try again. Share. Oh, why have the resume share? Why sharing it says powers? It's kind of weird. Give me a second. Let me look into what's going on here. Let me do that again. Stop sharing, new share again.
You need a new laptop with Apple M3.
Is the how about now? Can you see? What I'm trying to say is keep saying it pause. Let me try. Okay, I have to try the desktop. See that work.
I see just a, okay.
Can you see now?
Yes.
Okay. Somehow I share the tab on the Chrome. It doesn't work to share this desktop. Maybe because I'm using a two monitor issue.
Okay. Yeah, maybe.
Okay, let me start on this. So yeah, thanks, David. And yeah, this we're just going to quickly provide an update on the material design kits. And it's a work in progress. So read by a few of us here, right? Including Tony, David, Java, and myself, and a few others members here has been actively participating on this, including Roger here, Andrew and a few other EDL firms like from the Cadence as well. So yeah, we overall we got very good participants. So we some of this slide you probably have seen before, right? Tony and others have probably presented before, right? Just give a bit of background. We doing this mainly for the 3DK, which is mainly covering the 3D IC design kits, which including actually both 2.5D and 3D design. And this is a work we try to leverage a lot on the materials and also the format that we have from CDXML and also the integration with the JEDEC. So we're also planning to integrate this new format into JEDEC later on. The JEDEC has been showing interest for taking the initiative for including this new format into their standard there. So and a bit further background that is this 3DK have many components. Again, this slide has been discussed before. So we have the CDK chiplet design kits. We have already done most of them. I think in our white paper before and incorporate some of them is already in the CDXML, and some of them has been adopting to JEDEC as well. And now we're working on the MDK, and also there's others like the assembly design kits, which we are also working on right now. And there are a few others like the focusing on the IP side, the process design and package IP, which is also part of this 3DK overall. So, and quick intro on the MDK. So from the name, all of you probably realize that, right? This is it's a collection of the data that kind of like describing the material information of components, mainly targeting the semiconductor here. So as the name implies here, right, a lot really focusing here is on the 3D 2.5D as mentioned earlier. So this includes the information on the the chip design, the PCB, packaging, all related to 3D and 3D IC. So we'll come to be a bit more about these properties and that give you an idea, what are the scope and coverage that we're talking about. Material is a big field, so there are some micro materials an array world, which we might not be going way depth into that. We want to cover, it's very important, I think, for this, we want to cover what would the actuators are needed, I think, from the semiconductor and chip design point of view, and all the way from the design to the manufacturing. So and to that extent only. So that's important so that we don't get into too much of details. I think where they require they need specialties, and which is not the focus of this the work group here then.
So James, just a quick comment. So material scientists, are they users or are they more the ones creating these kits? They're authors, aren't they? They're not going to be using these, will they?
Yeah, I think I think they are user in general, but I think there might be there will be some scientists as in general as a kind of creator, but they also potential user also. We have seen, I think, as mentioned, especially I think on assembly and manufacturing side, they are actually working more on details, I think, into material side, for example, I think in the assembly when there's certain kind of the the soldering and things like that, when they are not really kind of or when there's a crack and things like that, I think where the material engineer to try and look into it, what is causing the issue, when there's a reflow reflow and things like that, right, tend to be there's material going to, I think they will need to look into that. So some of this information will be useful to them, like what material consists of those components, and then they can do analysis on it.
Yeah, it's a little subtle, but I like to think it more of as a supplier and a customer, right? The material guys are developing the materials, they're defining the material properties, and then the users are the ones who are actually doing the simulations. And sometimes the simulation guys will kind of define the material requirements in the material guys. So I think there's some back and forth, but I just don't think the term.
Sure, I think we can probably, I think I put that use.
Okay, so you said useful. Okay, got it.
Right,
Okay, thanks. Yeah, I missed that. Okay. And by the way, I don't know if I mentioned this to everybody, but I was in Japan a couple of weeks ago, and I met with one of the biggest material providers for semiconductor in the world, Resonac, and I gave them the 3DK presentation, and they were very interested. I mean, these guys have they have a whole kind of pilot facility for assembly, and actually can do some assembly and building chips and minor fab capabilities. And they have a group in California, and they want those two of their members to start participating in the MDK. So I give those contacts to David, and David, just make sure they're on the invite for next week.
Okay.
Did you get that? I sent it a couple of weeks ago, but just let me know if you don't have it. I'll resend it.
A couple of weeks ago, I was in a holiday mood, so probably didn't.
Okay.
If you wouldn't mind just resending that email, that would be awesome.
I'll resend it. Okay. But just in general, I also presented at the Semicon Japan, the 3DK, and it was very well received. So there's the government is investing a lot of money in fabs and packaging, advanced packaging, and they're not really interested in adopting 3D blocks. They're looking for something that is a little more, neutral, and I think what we're doing has some broader scope in terms of what TSMC is doing. So I think we're getting global interest in this, is the point I'm trying to make. I haven't really done a lot of promotions in Europe, but we should probably poke around there as well.
Right. That's very good news. I appreciate that. Yeah, Tony, if you can also share, I think, who new people, I think, so we can anticipate, right, who participating, and see and get them to prepare for them to contribute. Thanks, right, Tony, for the quick updates, right? So this is just kind of like, I think, a snapshot. I think in general, I think some of the data, I think that what we're trying to cover here. I think but I'm going to share a bit more in details in the spreadsheet, that actually more in details that we're covering. So high level, I think you probably can see in high level, I think like this, right? This kind of like the thermal kind of like the variables like conductivity, like there's a density, like CTE side, like the DK, DF, even surface roughness, tension strength, a lot like to do with the mechanical, thermal side, that we trying to look into these properties that use into many various stages of process. of the information that would be used a lot, like analysis, like whether at the silicon level or at the package levels, or even at the the chip level, such as like the BOM and things like that. All this material information will be useful, right? When doing like thermal analysis, like the stress analysis, and as well as like the to even to some of this, like the how the surface connect each other, for that, like surface roughness and things like that.
James, quick question.
Yeah.
On the units, Young's modulus, is the intent to keep it as Pascals, or typically they're very large values, so the typical value is provided in gigapascals?
Right, that's a good question. I think like here it's just kind of like for an example here. I think like it depends on where it's like used, right? You're right. I think like it could be like gigapascal, especially when talking to that more kind of like very small area. I think like the peak point. So and it could be a different kind of unit as well. It depends on where this unit are using. So it could be a kilopascal. I think you're right. I think that's more appropriate actually. Kilopascal, I think generally just kind of used without that kilo there, but I think that could be here in most of the cases.
Yeah, yeah, because okay, yeah, and probably this as for surface roughness, you have microns. I thought that this is in nanometers usually, no?
It could be. I could be. I mean, like, I just kind of put in there as kind of like example. I think like it depends on where's the use case. I think most likely it could be in what you just said. I think I just kind of throw here for the as a sample data here.
So
this is not the final format. It's just kind of like for a snapshot kind of data and example unit we're trying to capture here.
okay, is there then if this is the base unit, is there an intent to basically the file format? Is it expected that it will define? Let me word my question correctly. Is it expected that the values provided are also going to include a unit, or is it going to be just values and the unit is going to be fixed within the entire format, not even the file, but the format itself?
Yes, I think that's a very good question. In general, I think we're right to include that Unix there. I think so that we can have more coverage on that. And we can have like some default unit. And then that can be all right, I think, with the unit fields that people want to include there.
Okay.
So yeah, and let me kind of just go into a few documents that we have. I think the main thing here is this the spreadsheet that way we started. I think most of work has been ongoing here. Let me see. Okay, it's coming up. So this is pretty much, I think, the spreadsheet like we collecting all the information. So for the material properties and trying to see like how we going to cover that and the scopes and things like that. So we started with the properties. Like we kind of break that into area like different like thermal, electrical, packaging substrate, and from there we kind of like breaking down further. I think into more like analysis point of the view. So we're trying to see like where the main analysis are used, and then from there we kind of expanding that to the use cases for every analysis, and then that's where I think most of the concentration of the works right now going on. So from all that's kind of like the different aspect, like from properties, from analysis, even from the components that we have reviewed, we kind of like came together and put like all this information into like based on use cases. So we should like higher world on the left, you can see define into like different components like from physical, thermals, like SI, PI, and also the mechanical, and each of them have different use cases. here, which is very kind of linked into like many different kind of analysis. What we will result into like physical. We have like kind of package selections. So you can say like in package selection, I think like there will be right material consideration here. So you can see material information. A lot of this information are actually taken from the white paper that we have been working on. I think that give a lot like the summarize, I think like from the input output table and give like very like a good coverage on kind of like analysis, what we're trying to do at various stages, from this the in full integrations like for which will cover most of the 2.5D and 3D. So and so that's why you probably see a similarities here. I think like from the input, output, and the persona, all this information and including the description are kind of taken from there and standing like what we has been developed and from different area expertise. Now we kind of expanding that for materials that we're trying to use. So the gray one is the one that we kind of like decided is not something that will be a priority or something that we're going to focus right at the moment. So we're going to look into the one that just with the white one. So and on the thermal side, I think like when we do like there's a use case I think like related to materials such as conductivity, density, spatial heat. So that's why we have this kind of like material information we're trying to expanding here, which including like conductivity, density, like the glass transition temperature analysis. And then there's analysis associated with that. So we're trying to, that's which is part of the exercise that we're doing right now. So we're asking, I think like people, I think like expertise kind of like providing, I think what the analysis will be used here. I think some of these things such as like the DSC, differential scannings, and also like some as TGA that will be useful here in the simulation. And from there, and then we can kind of look into like what are the input and output for that analysis required. I think that's helped us to expanding the actual material properties that will be needed here. And then and further along with that, which we plan to do next is like which we're going to add also like potential additional information, right, such as these environment conditions and things like that. Actually, I think this is in the mechanical. Okay, I don't know why it's here, but anyway. And then we also thinking about like including some of the tools that we're trying to look into, such as like different EDAs company have different kind of like analysis tools, right? Kind of like give some example like what kind of tools are using there, and then from there we can also like extract and look into more information like what material information might be needing there. So that is kind of like another exercise that we are working on right now. And one more thing is like the model. We also like thinking of also cover some of the like models information. We're trying to look into some of the specific model that might be used in the specific analysis and use cases. Again, that will be give a lot of informations might be needed for that models from the materials side. So that's what we want to cover. I think like some any generate or specific models that will be used in specific analysis, and that mainly again like going to give like make sure that we can cover like support on those models for me. Essentially, at the end of the day, I think where I think this material information will be used a lot in this kind of analysis and some of this tool and some of the model as well. That's why we want to make sure we have a good coverage and how that material information properties will be used, and that gives us the insight and how we're going to create a format supporting that. And from there, I think then we're going to we also talk about we might potentially supporting like different kind of like format of the data beside the numeric or string values, which could be like a file or graph. So something that like when come into a needs on that, we're going to define like they will support like in the XML, which is one of the format that we have been like decided to use to support on this format. So yeah, this is kind of like very extensive, right? Graph, like as you can see, the graph table, as you can see here, I think that's what we, the team that we have been working on. And on the vertical, we have been extending, I think on different use cases here. We and including, I think some of these, the powers, I think, this decoupling, I think this is a bit micro information. We decided we're not going to include that in the scope here. But on the mechanical side, we do have a lot like coverage here, like such as the when we looking into like material property specification in the mechanical side. So we are looking into a lot like the molding side. So where I think like this kind of like hardness, stress, will require a lot of material information here. And further expand here, I think you can see there are a lot like structure here, especially I think that is which you guys expected. I think I really tie into a material. So and then like you can see the examples of analysis has been included here. It is linear, non-linear, thermomechanical, and some elastic kind of like structure. I think like they have like material property kind of associated with that. So that is so far I think what we have. I think that we're going to continue expanding this table and to cover like completing this analysis, and also like the material property analysis, and all the tools and the models will be needed there. I think once we done that, I think we should have a very good coverage, right? What we should be covered, right? In this work stream or work group there. Quickly share with you though some of this thing. I think team like for information. I think this is is kind of master. Hold on, yeah, it's kind of more like a master spreadsheet. So you cover kind of high level. Some of this thing that we will have some of the member of the teams have been covering more details, such as like Andrew, right, from the NSYS has been kind of like sharing, I think like a lot of information that at the NSYS that has been used for the material properties for the simulation there. So if we expanding from some of that structure here, I think you can see linear, non-linear here, and elastic. I think where there are detailed parameters will be covered here. So which including the model and the parameters, and also as other factors as well. So this is pretty extensive here. I think we all these things eventually I think will be good information that we can start putting into the XML format. So that's kind of example exercise what we're trying to do. We have some good coverage on some structures areas here already. So we expand with that spreadsheet. So we continue to expanding some other areas, including mechanical, signal and power, and as well as some of the thermal as well.
So James, just a quick comment. I mean, this is a very comprehensive spreadsheet, and there's a lot of stuff here. But I think we did agree we're going to try to get this sort of wrapped up by the end of last year, and start coding some of this up. Do we believe we're at a point where we can start?
I think we can start some of them, like the structure. We have a good coverage there. I think especially with the one that it's around the mechanical. I think we have a lot of information. I think we can start here. I think some idea. I think we potentially can do in parallel. While we're doing that, we continue to solicit information input on this signal, power, and also the thermal areas. Even physical, I think very related to the structure and the
I would suggest maybe in this order we do thermal, signal, power, integrity, and then mechanical.
Are you saying in that particular order, or?
Yeah, Yeah, I think thermal will probably be the most straightforward. I think it'll be good, just getting something down as a starting point. And as we start building these, I think the structure will kind of fall out and we'll learn a lot. So I think we want to start with the easier ones, and we can build some simple test cases. In fact, we already have a test case, so we can start using that to support our CDX demo. So what we did in the CDX demo was a little bit of SI, some precursors to SI and thermal. So those are, I think, why I'd like to do this first.
So Tony, when you mentioned power before mechanical, what did you have in mind about that?
For power integrity analysis.
What values specific that we need for power integrity?
You tell me that. Do we have that captured here?
So it would be the same list as SI analysis, Tony.
It's pretty much
Right.
They're identical.
Okay. Exactly.
So it's really it's primarily IR drop, right? So you're looking at the
or AC impedance analysis is the other thing that's right there for PI analysis. You have IR drop and AC impedance.
Yeah, so
are the two
essentially
kind of
it's
key metrics.
RLC extractions, whatever we need to support those extractions, right?
Okay.
Yeah.
Yep. So I think that's relatively straightforward. And it's you're right. I think it's the same for SI and PI, so it can kill two birds with one stone.
Yeah, absolutely.
Yeah, that's what I was thinking too, that SIPI is the same thing.
Yep.
Yeah.
Well, it
think I
uses
have
the
this
same
step-
stuff. It's a different thing.
Yeah. I mean, in terms of material definition, is probably is the same thing.
Right.
Okay.
Yeah, I think that makes sense. I think we do have John here. I think John is a lot expecting in this area. I think I just we're going to help. I think to provide all information. I think on this SIPI related to the mechanical instructors.
Yeah. And it's good we have optical, but I think that's a long ways away from when we're ready to look at that. But we could probably even just define some of the material properties. I don't know if we have anybody in the group currently, but when we're at a point where we want to start capturing that, we should probably start trying to look for somebody. I know Cadence has folks. ANSYS as well. So
Right.
And Siemens is a big company. We may have experts as well. I just don't know anybody.
Yeah, maybe we can check with Andrew on that and see if we can get additional feedback on that area.
Right. So I think it's a little bit premature for that. So let's walk before we can run.
Yes, I think we do have good coverage on many of them. I think we can start kind of putting the structure together that we can and right you say I think that's a very good exercise. I think that we can kind of look into form into a shape and see we can capture most of this information and see any kind of unique requirements. I think that we can cover as well. That's very good. I think I'll put a note here, so I think we going to be included.
Right. So many of these properties are probably applicable for multiple flows, right? So have we figured out how we're gonna organize things so we don't have to replicate everything?
Yes, I think yeah, that's probably another good point. I think once we put all this together, I think then we can see into if we can make it more modularized and reuse many of these, right? Kind of like the format made different areas. I think one example which you already talked about, I think in the SIPI, they kind of like definitely I think I can reuse almost like the same, I think information there in the same format. So we probably can kind of like.
Yeah. So maybe even, we could do like a table that has all the material properties, going down the column, and then we can have each of the rows a different type of analysis, and you could just put an NA or applicable for each of those. That might be a nice way of organizing it.
Yeah, we can probably have another spreadsheet. I think I look into from different dimension there. I think driven by the materials, and then see what it covers. Like, yeah, what analysis I think will be covered with the same set of material information.
Right. So if somebody's looking to run, the SI guy, he can just filter to, what are the properties I need for SI.
Yeah, that makes sense.
Eventually, these tables will be helpful in kind of a GUI or a user interface for this. At some point, we're going to have to develop that, or someone will have to develop it.
Right.
I believe ANSYS has a tool that does that, and I believe Keysight does as well.
Right. I think that makes sense. I think for a lot of user point of view, I think easy. I think for reference from that point as well.
Which reminds me, I need to ping Keysight because I did meet with them about a month ago. They're interested.
Yeah. Right. Right. If you can, I think I remember you mentioned that last time. So if you able to get them, I think to participate, I think that would be very helpful. Yeah, I think that's. By the way, thanks Tony for sharing that. I think the comments there. So I think that's so far I have. I think to share here. Anyone have any questions, comments?
Yeah, James, can you go back to the list of properties?
Yeah.
Okay.
This is where we started actually. I think we're more focused on the use case right now. I think some of this information we kind of can grab. I think some of this may not be as updated. So yeah, don't worry too much about this. So I think focus is on the use cases right now. I probably maybe can be organized.
Yeah. And I wanted to make sure that we have everything that's needed in there. Yeah, okay. I think what did I see? Oh, okay. Yeah. I'm confused. Yeah, I was looking at this and yeah, never mind.
Yeah, I think
yeah, I'm not seeing a small discrepancy between here the heat capacity, specific heat capacity, and in your slides you had it just as heat capacity with different units. I wanted to make sure that we follow the units and the definition here in the spreadsheet.
Okay.
I think.
I probably should also include that since we're expanding more into this field, I think I probably include that units here that I think I saw to be more yeah, probably I think that we I think to be very that way. Since we're expanding more information and put into it, this is kind of more like master spreadsheet. So probably cover a unit here, I think so that is yeah.
Okay, this looks good. I'm definitely looking forward to starting to define the format and the description.
Yeah, we'll work on that. I think so like race we can talk more about this thing. I think you're going to start looking into how to start as proposed just now. I think with the thermal and then like this SIP and then after that then we go on this structure. I think so and that hopefully I think I will also shed some light. I think I shed some light. I think on the some of these information like the units and potential other graph and things like that, or table information that we may be able to support or not, or how for sure we can support, but how we can support that. I think that will be very good. I think exercise to start with. The quick thing, and then just one quick share. I think it's one of the documents. I think that if you send out that the minutes meeting minutes, I think to the group. I think and that include the link to that. This is a document. I think this is a way all kind of copy a way. That's where we started. But eventually, I think when after we start forming this structure and informations, we're going to update this document, including will be referenced into this spreadsheet. Essentially, I think this document will be used as a handoff. I think to anyone. I think interested in integrate, especially in data. Like most will be integrated. I think with the information here. So I think this will be as a handoff kind of document, like same as like what we have done before using CDXML. We're going to hand off this document for integration there. Essentially, I think this potentially can be good, right, for some a simple white paper as well. Yeah. Any other comments or questions? If not, then I'm going to stop here. I will be around. I think Tony, they will be around. Anyone have any other further question? I think can always kind of I ask at any time. I think in this CDX meeting. So yeah, David, I'm going to hand back to you then.
Okay, thanks.
Yeah, thanks everyone.
All right, let me find my window. Okay, so I updated already the calendar invites to 55 minutes, so you guys should see that change in your inboxes. Next week, Kevin, are you still around? Are you still here? Yep, Kevin, you are up for the federated simulation of triplets.
Yep. Should be good to go.
Okay, I know you told me you have the slides, so you have another week to add a few more slides. How much time, by the way, would you need for your presentations? For your presentation?
I'm not sure how long it'll take at the moment. It's supposed to be nominally 35 minutes at the Chiplet Summit.
Okay.
And then Q&A.
All right. We'll give you 35 minutes, and I'm sure we'll be interrupting you in between. Okay.
Yeah. Okay, sounds good.
So Kevin is up next week. Anybody else who would like to present to start the new year by presenting something new and cool? You don't have to answer right now. You can send me a message.
So David, do you want to spend a minute or two talking about their OCP demo?
Yes, exactly what I was going to switch to. When can we start on that?
Now.
I mean,
we only have 5. Oh, I thought you were talking about it. We have 5 minutes. Yeah. Let's talk next week. I think we should sync up, with everybody who's working on it. I sent you an email today. It looks like we may have a grad student who may be willing. So I want to see if we can see if he's an option, and then we can set up a call.
Okay. So I'm a little bit worried in terms of the RTL aspect of this. Do you expect that somebody's gonna write the RTL for the entire system?
Yeah, but it's going to be a very simple system, right? I mean, so essentially we've got a bunch of processors, right? So we just need to hook them up to an interface and be able to put data in and out. So I think we can contrive a very simple structure. That's my thought.
I'm not. The CPUs, I'm not too worried. I'm not worried at all because RISC-V comes out of the Chisel compiler already to go.
Right.
It's everything else around that I'm worried about. Because we have to add active buses. I don't know if we're going to add NOx, and we have an external memory that we might want to talk to. So
yeah, I think let's keep it simple. Let's just. I mean, it doesn't have to do anything real, right? But it would be nice to run a simulation that does stuff, and just run some basic code that does something,
basic code just on one CPU or even around between CPUs?
Around in between. So I think we want to do something interesting. So I think we can come up with this, generate some interesting test benches that'll kind of have everything cranking away and different speeds and that kind of stuff.
Okay. Yeah, so for that, in terms of libraries, I have the NAND 45 library.
Mm-hmm.
There is OpenRAM compiler that can compile memories to that process. I don't know if
we do have a compiler for that process.
Yeah, it's open source.
Is it register based or is it real memories?
It's real
SRAMs.
Yeah, it's SRAM.
Oh, really?
Yeah.
I wasn't aware of that.
Yeah, we are limited to. There was only a limitation. I forget whether it was one read, one write port or one read write port. There wasn't two read write ports, but that's usually okay. At least
it's fine.
Very simply okay. Yeah, the compiler can compile it. I think I haven't followed the development of the OpenRAM. I know they updated it for the Google MPWs, whatever process that Google does. They have an update for that.
Can you send a link for? Is there a website where we can see what's available?
Yeah.
Just post it in here.
Let me do like this.
You don't have to do it.
Yeah, just if you search for OpenRAM, and there you go, openram.org.
And what about the standard cell library?
Standard cell library, it's open source. I have it. I don't know whether it's still hosted somewhere on the internet. I can send you all the tar bundle once we get there.
Okay, but it would be good if we could get a link just to know where.
Free PDK, the Apache 2.0 license from SI2. Probably you have to go download it from SI2, but since Apache 2.0 license, I have it. I can download it. Oh.
So it's free, right?
Let's see. They even have free PDK 3.
Yeah, it's from NC State. Yeah, they got PDKs also, right?
3 nanometer. Oh, look at this. PDK 3 nanometer free open source PDK.
3 nanometer?
Yeah. But that's a PDK.
Oh, just a PDK. Okay.
Yes.
So they're throwing out there and hoping somebody will build a free library out of it. Right?
Yeah, they have NAND, they have flip-flop, and good enough layout.
Nobody's got any IO libraries.
Yeah.
Well, you know, we can, sure we can hack just the simple binder buffer just so we can set some controls, but most of the stuff, if we just, you know, deal with the HBMs and all the die-to-die stuff, that's all die-to-die files, right? And HBM and above.
Yeah, we are gonna need, actually, for the
We're
bulk,
gonna need to get that model. So, I'm not giving up on that.
yeah, Bo, we have to double check, by the way, Bo released link layer RTL. So we may be able to hack something through there. We'll see. Yeah, okay, let's, I think we have quite a bit of on our plate then to work on this demo.
Right.
So in the
right,
meeting, we should start with defining exactly what we want to do and how we're going to do it, and just because we need to do that quickly.
So I know we want to do a bow since it's OCP, but I can probably get a UCI Express. So that'll be my argument. If you guys don't give us a bow model, then we're going to go UCI Express.
Okay. Yeah, I'm fairly agnostic whether it's UCAE or bow.
Yeah, I mean, ideally we could do them both, but
Yeah.
But
yeah.
Just okay.
Right.
So I'll let you know once I hear back, and we can. Yeah, I think we should set up a call next week with the key stakeholders. I know Mark was interested, and Ahmed, one of his guys, so we can pull them in.
Yeah, and James is interested. Are you going to set up the call, or you want me to set it up?
We'll figure that out later.
Okay. Do you want to talk about what time works for everybody? I would, if we had, usually we used to meet on Friday, early Friday, right? So before 10 Pacific works for me, Fridays.
Yeah, Friday mornings I think are pretty good. What time? What do we do?
I can do 7 on Fridays. That's fine too. Yeah, my son got his driver's license, so now I'm no longer I'm no longer full chauffeur in the morning. So
Hey, David.
I guess.
Hey, Happy New Year to all of you, man.
Hey, just Happy New Year.
I just called in a little bit late. Okay. Anything else? Otherwise I need to take care of something else.
Yep, we all need to drop off. So any last comments from everybody? So Tony, let's sync up offline on the demo stuff, and let's get that work going.
Yeah, I think 7 would be good. 7 or 7:30 on Friday.
All right. 7:30, all the better.
We do have 8 o'clock Friday, right, on that OCP ODSA update meeting. So would that be overlapping?
Well, I've got a standing meeting at 8:30. So
Okay.
Would 10 okay for you guys Friday? I think that what used to be on Friday time, right? 10 a.m.
10 works.
Would that work for you too, David?
10 works for me.
Yeah, 10 works.
Pacific. Does that work for everybody, John? I think we lost the crowd.
Yeah, let's sync up offline on that.
Sure.
All right, guys. We'll meet again next week, and Kevin, you're on tap to
Well,
do
we're meeting in an hour, right?
Oh, yeah, well, yeah,
Okay.
I mean, this CDX meeting meets
Right.
next week with presentation from Kevin.
Right. And is Satish presenting? at
No.
3DK?
No, I think like last time he said not on the first week, so you can give it a couple of weeks.
Okay, so what's on the agenda?
Well, we're just going to follow up, I think, like on the what we have so far, which is the we have expanding, I think, like some of this view. So I think like on the, let me quickly open that update. So
No, we can cover it then. So you're just going to do an update on what we have. That's fine.
right.
Yeah. I've got another call that I got to jump to.
Okay, all right. We'll talk to you guys in a bit.
Okay. Thanks, guys.
All right, thank you. Yeah.
Bye.